Hello, a warm welcome to all of you. Thank you for joining our Smart City Talk on future mobility today. My name is Felix Kalkowski and I'm with the Korean-German Chamber of Commerce and Industry, and we are co-organizing this webinar together with the Friedrich Naumann Foundation and KAIA, which stands for Korea Agency for Infrastructure Technology Advancement. Our speakers today are Dr. Taehyun Cho, Chief Director of the National Strategic Smart City R&D Program at KAIA, and a member of the Korean Presidential Special Committee for Smart Cities. Dr. Cho will be giving our keynote for this session. Professor Hwasoo Yeo from KAIST is a mobility master planner for Sejong City. Professor Yeo will be sharing insights from Sejong's mobility strategy. Afterwards, we'll hear from Ms. Hyun Lee from Hyundai Automotive Group, AUTOEVER. She will be presenting Korean Smart City mobility projects. Dr. Christian Tags from the Friedrich Naumann Foundation will be co-moderating this session together with me. After the presentation from Professor Yeo and Ms. Lee, we will have chance for a panel discussion. So please submit your questions through the chat function. We will try to accommodate as many of your comments and questions as possible. Now, without further ado, it's a pleasure to pass over the microphone to Dr. Cho. Dr. Cho, the floor is yours.
Good afternoon. I am Daeunjo from KAIA. I am in charge of National Strategic Smart Cities Program of Korea. I am pleased to be here for these smart city talks, especially for future mobility. I deeply appreciated for the contributory works of Friedrich Naumann Foundation, Korea, and the Korean-German Chamber of Commerce and Industry. I would like to give thanks to our speakers, Professor Yeo of KAIST and the business manager A. Lee from HYUNDAI AUTOEVER. As we know, it becomes clear that the mobility is critical lifeline of cities, and at the same time, it is another type of human right to move under the COVID-19 pandemic situation. Around the world, most of countries are suffering from second and third outbreak of COVID-19. Economic recession is long-standing, and a number of people are stricken by the shortage of income and losing their jobs. We are facing the vulnerable point of recent public healthcare system in the area of detection, tracking, and treatment against the coronavirus. Even if the good news for the successful test of a vaccine, such as Pfizer and AstraZeneca, is coming, but the realization of collective immune system will be projected to come next year. In Korea, including Korea Disease Control and Prevention Agency, most of government ministries and organizations have put great efforts into overcoming this COVID situation to bring our lives back to normal. Among these activities, Smart City Solutions gave a big contribution to detect the confirmed patients and monitor the self-quarantine people from their home and offices. For example, the Smart City Data Hub has contributed to integrating the telecommunication data and credit card record in one platform, which makes the epidemiological investigation process easier and faster. I think this smart city technology will accelerate the digital transformation, and on-contact solutions such as teleeducation, telemedicine, on-demand logistics will be facilitated. Today, I hope the speakers and the audience share the knowledge about future mobility, such as infra and autonomous vehicles and the smart city solutions, including artificial intelligence. I hope also this seminar will strengthen the relationship between Korea and Germany. I believe we will overcome this crisis as our ancestors always done throughout the history. I wish everyone with us today stay healthy and take care. And thank you for attention.
Thank you very much, Dr. Cho. It's a pleasure to hear your welcoming remarks. And now, Professor Yeo, it's your turn. The floor is yours. We're very much looking forward to your presentation on Sejong and the mobility strategy there.
Okay, hello everyone. Guten Tag. My name is Hwasoo Yeo. So I want to talk about the Sejong Smart City. So especially, I work for the smart mobility strategy and the planning. So I'm from the Korea Advanced Institute of Science and Technology. Okay, here. So I have two items. The first one is the National Smart City Testbed. I want to introduce our efforts and our plan that will be done for the next 5 years. And then I want to talk about how we can build this kind of the smart cities and what is the philosophy and what is the strategy and what is the real implementation issues that I want to share my vision with you today. Okay, so I want to introduce Sejong City first. Sejong City, this is originally designed as a new capital city of South Korea. So we want to move to our capital city to the Sejong area. But right now, it is just a government complexity. So meaning that all the government offices are surrounded this Sejong City. And so one more strength is that around the Sejong City, so most of the research institute in South Korea they are located in this region. And the National Smart City Test Bed, you can see on the right figure, it's just one district. So marked in the circle. Then this area, so we're going to build a new city. The city will look like this. The total project cost will be around $30 billion US, and the construction period from the next year, and it will be about 5 years. And so we're going to start operation, so from the year 2021 to 2036, and the business will be done by the O1 consortium, so led by the LGCNS. In this area, so we're going to propose the 5 mobility services. The first mobility services will be the personal mobility. As you think, we're going to use the electric kickboard and we're going to use some of the bike systems. And then we will introduce shared mobility and autonomous shuttles and demand responsive transits. And so one more is the smart parking. So in the 5-1 district, this is the smart city testbed area. So based on this area, so we're going to plan the city transportation systems. And then, so later we're going to expand the experiment to the whole Sejong City. At the core of our effort, so we have O1 link. This is implementation of the MaaS. I think the European peoples are very familiar with this MaaS concept. This is a mobility as a service. Using just one single application like the O1 link, so you can reserve and you can pay and you can plan your trips. So this one, the O1 link, so we're going to provide the multimodal services to everybody. So from the 5-1, the testbed locations. And one good thing is that this O1 link, we're going to open this platform to everybody. So meaning that if we are running a business and if we want to do some more mobility services, then you can also use this O1 link so you can join our network. Under the O1 link apps, we're going to build the O1 mobility brain. This is kind of the system that optimizes the transportations and the mobilities using AI, cloud, and big data. Inside this O1 mobility brain, I think this O1 mobility brain is the core concept of this O1 link and this smart city. So we're going to implement a mobility simulator. so to find the optimal travel, and also we're going to predict the future demand and future traffic, and so we're going to provide these services to the people. Using this O1 link, you can plan your intra-city travel using the 5 mobility services, and also these services will be combined and integrated so with the existing services in the Sejong City, like the BRT, bus rapid transit, and the bus systems and taxis. And also this will support for the intercity travel. So if you want to go to some distant cities like the Seoul and Daejeon, then you can still use this O1 link. Using the O1 link, just one click and just one app, you can reserve everything. And the personal mobility, we already have some personal mobility operated. We have some bike, so we have some kickboard, and we have some micro mobilities. So here, to improve the safety of the micro mobilities, so we're going to build a personal mobility roadway. So this is separated from the pedestrian way, and the bikes and the kickboard, they can use this roadway. And for the convenience, so we're going to use the wireless charging system, and we hope that so all the energies for the electric bike and electric kickboard can be provided by the solar energies. What we aim is that the total energy consumption inside this testbed city, so we think that the 40% of the total energy demand can be provided by the solar energies in this city. And to connect to the vicinity area, so actually in South Korea, Uber-like service is prohibited. It's illegal services. So we want to have a little bit different type of the shared mobility. So we're going to use the rental car services. So around this area, we have 5,000 the rental car services. Then, rental cars available. Using these rental cars, so we're going to connect them so with the O1 link, and then the people living in this testbed city, they can go to the vicinity area using these rental services. We can also provide a one-way trip with the free floating services, meaning that you can just, so when you arrive at the destination, you can leave your vehicle, and the handler that we hired will handle that vehicle so that they will bring back the vehicles back to the stations. And also we're gonna have more services like the car delivery and the driver services. And so we are making some kind of flexible pricing, pricing strategies. So we have two types of these services. The one is the station type, meaning that you can go to the station and you can get these services. And there's one more, that's the free floating, meaning that you have to find the vehicles using the O1 Link app, and then you can leave your vehicle anywhere, then the handler will handle. And there is one more thing. This is the autonomous shuttle services. Inside of this area, so we are planning 2 autonomous only lane, that around this autonomous only lane, we're going to first run the shuttle services first. And then, so this area will be connected by the CITS services, so by the national government. So using some kind of infrastructure to vehicle the communications, that they can get some more information from the infrastructures. So along this roadway, we're going to install so many sensors. So here, so we are designing smart pole. Smart pole is the kind of the sensor combinations. We're going to use the CCTV cameras, and we're going to use the LiDAR or radars if needed. And then those information will be delivered to the driver or the vehicle so that they can avoid some kind of the very dangerous situation like the collisions. And for the security purpose, we're going to use the blockchain-based security. And so we will make a smart shelter bus station, meaning that the smart shelter is kind of the O1 link accessible point. So if we just go to these bus stations, even though you don't have any apps, you can reserve the services and you can get the service. These autonomous only lane services will later extend it to the whole cities because we do not sure, the safety is not guaranteed yet. So we're gonna do some more experiments one by one, and then when you have enough level of the reliability, we're gonna extend these services to some other roadway. These are the test vehicles in Sejong City. So Hyundai Motors and some other research institute, they are developing autonomous vehicles, and they are So yeah, they are doing a lot of experiments. So from next year, so we're gonna use Hyundai Motors, the vehicle, autonomous vehicle to be operated on the BRT line. And so we think that one of the killer application of the mobility services is the demand responsive transit services. Demand responsive transit means that you are calling the transit services, and it can pick up you, and then so it will deliver you to the location that you want. We have two types of the services: the fixed stop-based services and the floating stop-based services. The fixed stop services, you have to go to the fixed stop locations. But the floating stop-based services, you can call anywhere and you can be dropped anywhere. So initially, we are starting from the 12 vehicles, but later, after analyzing some demand and mobility situations, we're going to increase this number so that we can provide the services to the whole Sejong City. And the last one is the mobility hub station. So mobility hub station will be located, there's around the cities. So you can see that the red dots and blue dots are the locations for the O1 mobility hub stations. If we just go to these mobility hub stations, you can get every type of the services like the bike, PM, the shared mobility, and the DLT, and EV charging, and more convenience facilities, and also robot parking. So this kind of the hub station will be installed in parking facilities, and some of the parking facilities will be the underground parking facility. So up to now, we are just starting from the 5 mobility services, but later we're going to extend these services to the more advanced future mobility services, like the autonomous taxis and the drone taxi and the UAM and so unmanned trams. So this will be also tested in the Sejong City later. Okay, so up to now, I have shown you some services that we are planning for the Sejong Smart City test bed. But the question is that, okay, this kind of services is just like that. So every cities are talking about. So what is the difference? And what is the implementation strategy? Okay, to look at this one, we have to rethink what is smart city. Okay, IT, data, information, they are talking about that this is just a smart thing, but I do not agree with those kind of ideas. So I think that smart means that the better decision or optimization. But how about the city? City is what? So there might be different understanding of the city. Living, lifestyle, history, all can be included as a city. But here, so from the management concept or from the engineering concept, so I can define the city is a system with many, many infrastructures. So what is smart city to engineers? I think that this is a decision-making system so for the urban infrastructure systems. So we have to make a better decision for planning level and the policy level, operation level, and at the very detailed control level. So this is my understanding on the smart city. Okay, to implement this idea, I think that we have to build a digital twin. So we want to make a copy of the digital version of our city. So like from the real world, we have to make maps and we have to make some behavior models. So but the problem is that, so how we can implement the digital twin? Okay, to make the digital twin, before we go into the implementation, so we have to talk about some kind of strategy. Okay, what kind of strategy we're going to use for the infrastructure management? So up to now, the infrastructure management strategies have evolved from the reactive management to the proactive and the predictive. And in the future, the automated maintenance will be the future theme. But right now, so what you have to focus is the predictive maintenance or predictive management. In the predictive management strategy, so we can use real-time data for diagnostics of our infrastructure system. We have to know the exact state of our infrastructures or our services. And then we have to build some prediction model. And based on the prediction model and diagnostics, so we have to set up some optimization strategy to provide the best service. Okay, to implement those kind of the ideas, we're going to design the mobility brain. This is the O1 mobility brain. I think that this is the advanced digital twin for mobility services. I'm going to show you some concept, some examples of the mobility brain. This is a core concept of the mobility brain. So we are starting from the data. If you look at the left top corner, you can see the live data. Using the drones and using the sensors, we can get data library. And then if we just look at the bottom part, you can see the live BIM GIS, the building information modeling and the GIS. So up to now, so many digital twins, they are focusing on building the data hub. But the smart city is not just a data hub. So how we can make a really good decision using those kind of the data. So we think that we need some more functions and the procedures. If we just look at the medium part, you can see that we are starting from the live facility diagnostic. Using some kind of the deep learning technologies, so we can exactly know the state of the current infrastructure systems. And then if we accumulate many of this kind of the data, then using the big data, so we can make a prediction model based on the data. So the upper lines are for the data-driven approach. But if we look at the lower lines, you can see that this is kind of the model-based approach. So as you know, if we have enough data, so we can do some kind of the big data-based approach. But the problem is that if we don't have any data, or if there is some kind of a very extreme event or never occurred event, then we have to do the simulations. So I think that the live simulation will be the core of this digital twin concept. And then using these prediction technologies and the data-driven approaches, we have to combine those together to get the optimal control and optimizations. Okay, to implement this kind of ideas, we can think about some examples. Okay, so we're going to start from the sensing. Okay, in these O1 cities, I think that, so we're going to make some kind of the surveillance system of the traffic. You can see that we want to track all the vehicles inside the cities, not just the vehicle movement. So we want to extract the origin and destination locations of the all vehicles. And then, so we're going to make some kind of the surveillance for the pedestrians. So we want to know the crossing intention of the pedestrian so that we can avoid some kind of the collisions. So this kind of system is the basic one. Using this surveillance system, we want to get the whole mobility data. And using those kind of information, we can implement some mobility demand pattern analyzers. We can stratify some demand into several ranks, and so we can extract some very crucial demand for the services. This information will be used for the DRT route services. And this information, we are using the DRT route optimizers. So at the real time, so we are observing the people's movement and the traffic data, and then we're going to make real-time route optimizers. And also at the core of the digital twin, so we want to build a cloud-based mobility simulator. Now, this is the example of the Sejong City. You can see that we are already building some HD map, high-definition maps for the autonomous vehicles in Sejong City. And so we are making some simulations. Using these simulations, we can make a much better route optimized result. And also, this kind of the mobility engine can predict and control the infrastructure system. For example, if we want to set the variable speed limits, then if there is kind of the accident and road work and the weather situations, the simulator will give the best result. What is the best action for the control of the roadway? And next one is the advanced AI traffic control for larger area. Using the surveillance system, so we are observing all the vehicles, and then the AI optimizer is calculating what is the best one for the signal control. But this kind of the signal control will be not just a simple single intersection signal control. So we're going to make a little bit higher level strategy like this one. This is the bi-level strategy. So meaning that we're going to divide the city networks into the several sub-networks. And for the several sub-networks, so we're going to optimize the interflow between the sub-networks, and we're going to optimize the intra-network signals. So as you can see that, so we can reduce a huge congestion so using the AI and this kind of the approach. And we think that we can reduce the very severe congestion in metropolitan area using this approach. And this is the last example of the O1 mobility brain. This is the PMS, which is the representative system of the digital twin. Using the drones, we can get the images of the roadway, and then we can remove vehicles. And then using some deep learning based method, we can do the diagnostics. So the computer will know that the road area will be danger or not. If there is kind of some potholes or the cracks or if there is some kind of the hazard to the vehicles, it will detect it. And later, using this big data, then so we can do the state prediction and we can give the maintenance optimization. So meaning that, so this is kind of this will be implemented as an order for to the maintenance workers. Okay, this is the end of my presentation. I think the Sejong City is the citywide living lab. So we're gonna do a lot of experiment here. And so this is what it pursues is that we want to have an open platform for business. So everybody who wants to join, so I hope so you can join this. You can just send me emails, and this is open for all type of collaborations. We're gonna build a smart city research center inside this region. And so yes, some the universities and research institutes will join this project. So it's I think that's this. Yeah, this can be a really good opportunity for the Korea and Germany collaboration for the smart city. Dankeschön.
Thank you very much, Professor Yeo. It was a pleasure to hear and find out more about Sejong and Sejong's plan in regard to its mobility strategy. I'm sure we'll touch upon a few more points in the Q&A in a little bit, but first and foremost, I would like to introduce Ms. A. Lee, who will be delivering our next presentation. Ms. Lee, the floor is yours, and we very much look forward to additional exciting mobility projects from Korea.
Okay, hello everyone. My name is A. Lee, working in smart transportation industry for smart cities. I'm working for HYUNDAI AUTOEVER, which is that the company is responsible for the total ICT mobility service for Hyundai Motor Group. Here is that the brief summary of my presentation. Firstly, I would say the several types of the smart transportation project. Second, I would like to introduce one CITS project, which I already have done as a project manager. And KAIST project, KAIST, comes next, which is the test bed to evaluate the automated car and scenario. Finally, I would like to conclude with further consideration. As for the smart transportation project, I'd like to say the key factors between several types of project. Here are the projects I wanted to introduce today. Those are the relevant projects which were already have done or still ongoing. So firstly, look at the left side of this project. KCT testbed, which is already have done 2018, and highway CITS project, which is done in 2019. And we are implementing that Daegu testbed 2020. So let's talk about that. The smart transportation project are about. So you're already aware of ITS project, which is already have been implemented during last 20 years. So what is that the difference between ITS and CITS? Most key factors is B2B, vehicle to vehicle communication. And also the last thing is autonomous driving testbed, which is the detection made without man. Now, I'd like to show that first case studies, highway CI test project. This project was led by KEC, Korea Highway, Korea Expressway Corporation, and here are the similar project which is already have done or still ongoing project. So first, we categorized those CITS project 2 phases. The first phase is Sejong CITS project, and second highway CITS project is which is already have done by Hyundai, and Seoul and Jeju and Gwangju and Ulsan, the 4 metropolitan city, they are implementing this CITS project now and still ongoing. And also, my company, my project team is joining that Gwangju project as well. As a project manager, I have completed this project for 1 year. Let me introduce a brief summary on this project. Project scope is 85.4 kilometers total length and 1 year period. And also it has adapt wave network to communicate with 90 RSU and 700 OBU. Also, it has 17 incident detection system to give the dangerous information to drivers. And also, it has parking information system as well as 1 center system with hardware and software. And also, this project is specially to collaborate and combine 2 different systems. Previous ITS legacy system in KEC, and also we combined 2 different systems, and it was really hard work, but we did make it. And this is a brief summary to show our services. It is 21 services, and it has 3 categories for safety and traffic management and road management as well. You can see that the color means that red color means that the critical information for driving and safety as well. So we implemented 9 services firstly, and also green and blue services. It is not looks like mandatory service. However, if you get the information of road condition and as well as that the different cases of event, then it helps your driving. And I will not say this 9 safety driving service details. You already knew that one. And also 8 traffic management service and 4 road management service as well. Especially we have 4 different types of tunnels and 3 different types of high-pass toll gates as well. And a lot of different events were happening in this road. So this is the simple scenario of trial performance test. After the project, our team set up scenarios and diverse events for trial. When the vehicle gets to the specific locations, the vehicle gets the event alarm, running and pop-up message through HMI and voice. Okay, here is that expectations for this project. in aspect of accident prevention, through this project, we can expect drivers' compliance increase, especially for almost 50% of compared to without information. And secondly, accident prevention prevention happen a lot, and accident prevention cost, it could be expected benefit $0.8 million. And also the other aspect of traffic flow improvement, just in case of 10% adaptation rate, speed increase 12%. And also in case of 50 adaptation rate, we can get the speed increase almost over 20%. Now, I would like to show that the other project, which is totally related to autonomous driving. When it comes to KCT project, it is a testbed project to evaluate automated vehicle based on systematic scenario. So whoever who wants to test their automated car, then they can simply make their own scenario to test their performance. Oops. Let me show you that simple video clip to introduce that system. This is the physical area to implement this system. Firstly, this site has community road, CBD road, as well as exclusive motorway and outer road, as well as auto parking area. Now you can see that the simple subsystems which can test during that drives this course. So firstly, you can simply combine this signal intersection information, and also you can test that the conflict effect with that incident. And also, this is that bus lane, so that autonomous car could be tested, that kind of conflict as well. And here is that CBD road, which has the shadow area with the high buildings. Now, this is a special zone for the pedestrian as well as the children. So you can simply test that the conflict between that pedestrian as well as small kids. This drone is to exclusive motorway course. So you can test that autonomous driving support system, which is ADAS. And also you can test the ACC. And also you can test that this high-pass toll gate. Now, here is a simple mimic of outer road, which is covered with trees. And also this is a roundabout. So mostly in this case, we have lots of conflict between cars. And also this is a tunnel. And almost lastly, that is that advanced smart parking assist system. So you can assess that kind of systems as well. And also this system has the control center as well, CCTV and traffic signal, also that the RSU and LCS kind of systems. Let's stop this video. Okay. Let me show you that simple explanation for that. It's the same thing. This shows the features of the physical site design. This course have diverse road types as well as specific situations. This is exclusive motorway, and those section is CBD area, so which can be tested for the signal area and bus lane and bus taxi stops and so on. And this is community road as well. You can simply get the events in the school zone and pedestrian and bicycle and road parking system. Also, this is outer road, which can have multiple shadow area because you can test that the telecommunication network service quality as well. And this is testbed details. You can assess performance under dynamic events with various conditions. So we already considered and reviewed all the things by video. So let's move to the next. And this is the expectations with as multiple points of view as a user, an operator, and sometimes policy and technology and market arrangement could be delivered. So this kind of testbed project can deliver those commercialization autonomous vehicle and autonomous driving market quickly. And this is further consideration. Hopefully, we should follow the standards and technologies. Those things should be arranged, and we should follow those things. So, especially for the standard, for the specific condition, road condition, and also we needed to develop diverse test assessment and scenario as well. And also we should follow that some standard map, such as LDM. And also we needed to have correspondence with CIT standard as well. Also, we have to consider that hybrid communication network. So that's all today. Thank you for that, your consideration, and as well as your dedication. Thank you.
Thank you very much, Ms. Lee, for that presentation. Very insightful as well. So this now concludes our presentation, which doesn't mean that the session is over now. Now we would like to, dig in a bit further and have a bit of a discussion. So to our online audience, you're still free to go to ask questions. Please use the chat functions. Some of you have already submitted some questions in the registration, so maybe we can kickstart with that a bit. So for instance, there was one question on autonomous driving. Basically, it was, we saw that there are a couple of test beds. There's a test bed in Sejong, there's KGCCI City, where in a closed environment, you can test autonomous driving applications. So the question there was, when will it become more widely commercially available? What is your take on that?
For me,
Sure, both of you can.
in my opinion, yeah, under my expectation or under my experience, it comes maybe next year or more 1 or 2 years later. We have that kind of pretty much combined system and policy we will have, hopefully.
Okay.
So, yeah.
All right, thank you. Professor Yeo?
Yeah, but my opinion is a little bit different because actually I'm the traffic safety analyst. So I think that the biggest the obstacle is that there's in the intersection locations we have a lot of difficulties. For example, we have many obstacles, pedestrians, and many objects in the intersection locations, and then so we don't have enough testing of the scenarios of the accidents in the intersection locations. So I think that we have to develop more accident scenarios, and we have to prove that more and more. Yeah, I'm very conservative because I was the safety side, not from the vehicle side. But yeah, so my expectation is that next 10 years, or maybe that's going to be, my expectation.
All right, thank you. Well, another question, since we have a couple of companies from Germany and other places tuned in, and I'm sure they wonder, okay, lots of exciting pilot projects. How can we get involved? So for example, Sejong, I think on your last slide, there was Sejong Living Lab open for business. What would you recommend and what would you suggest to companies who are interested in getting involved there?
Okay, yeah, so actually from next year, so we're going to start this business. So we're going to start our construction from the year 2021. And then so we're going to build the Smart City Research Center. And this research center is open to everybody. So if you are interested in that, so you can just send me email and so we can talk about how we can collaborate together. And also maybe some companies, they can use the platform. So platform is that the OneLink softwares or the Sejong City itself as a living lab. So you can also, just work together to test your, your product. So we are open to you.
Okay. Maybe a follow-up question on the O1 mobility brain, if I may do so. I thought it was a very interesting concept. So from my understanding is, so with the data, there's a lot of data that is being collected in the mobility brain, right? And how does it work? Is it like open data? Would you make it accessible for, let's say, stakeholders, companies to develop mobility solutions based on that data?
Okay, there are two things. The first, we're going to use open data, and so we want to open as many the data as possible. That's our strategy, and that's our government strategy. But the problem is that still, that there are some crucial data. Some data has some personal information that cannot be used by some companies. So I think that to solve these problems and to make more business model. So in this, the Smart City Research Center. So we want to, we want to let some the companies involved inside this building. So meaning that, so we're going to open some open spaces for the companies, and they can come here and they can use internally together to develop a new product. So this is two strategies. So we can open as many as possible, and then so we're going to open our spaces too.
Okay, thank you very much. Ms. Lee, you covered projects with K-City, which is more of a closed environment. And I think in Sejong we have the shuttle service on testing on autonomous driving. Are there any other autonomous driving projects on the horizon that we should be aware of? what are the next projects, maybe in the real world, that we should look out for?
As I mentioned during my presentation, one other CITS project in Gwangju, we are implementing that the CITS services in that area, as well as we are designing that the 5G based autonomous driving test bed in Daegu. So at the end of this year, maybe we will have that whole final report of that project. So yeah, it would be helpful to consider this business or system.
Okay. Thank you very much. Dr. Tarks, maybe a few comments, questions from your side? I think you have a few as well.
Yes, of course. Thank you very much for this really inspiring presentations you gave to us. I would like to go a little bit deeper into the role of the pedestrians. Which role do they play in your considerations? Of course, I'm rather sure that you will answer they play a key role, as so many other players. But to make it a little bit more easy to understand for simple minds like me, in the end, what would you think would the role of the pedestrian be? A stronger one or a weaker one than we have it today? Or is this just a naive question?
Okay, so yes, if I give some best simple actions that we think that the pedestrian, the role says, there is no role. Yeah, so we think that the pedestrians are some things that we have to protect from the very dangerous vehicle situations, and that's the one thing. But still, this Sejong Smart City, I just talk about the mobility services only, but still, as a citizens or as just a user of the services, there are a lot of laws of the pedestrians. So this is a kind of the living lab. So meaning that, so we have a lot of the citizen involvement, and they can give some opinions, and they can provide some feedback. And so actually in Sejong City, we already have more than 8 living labs, and each all led by the pedestrians or citizens.
Oh, I even have the privilege to ask another one, and I use my privilege. So with AD, what do your company calls itself HYUNDAI AUTOEVER. We all agree, I guess, that yes, this is not the end of the car, but it's some kind of a revolution, and it's a new era of mobility. What do you tell those people who like driving their car, who are not attracted by autonomous driving? Is it that? I'm asking because I see the density of expensive German cars here in Korea. I don't have to name the brands, you all know them. Is even higher than we have it in Germany. What do you tell these people? They have these cars because they like driving.
Oh, it's too much difficult question to me. Even I cannot say about the proper answer with this question. However, hopefully, yes, we will have the kind of condition which the drivers can drive safely, even though we have the lot of autonomous drive cars without men, right? So I'm not sure that what's the exact answer, but that's why we are digging this technology as well as this kind of pilot project to mimic to that and adopt to that kind of system to the real world. So one of the cases we are implementing now is in Daegu. It is considered a kind of condition with the normal drive car with autonomous drive car. So hopefully I have the solution after this project. Thank you.
Yeah, maybe it's good to keep the business card of Professor Yeo, because they are so intensively working in the living lab field to learn more about the needs and the desires of the users, starting from the pedestrians and not ending with people driving their cars autonomously or by themselves. I guess it's in consideration in your field as well, Professor.
Yeah, right. So actually, I'm one of them. So I'm the one who enjoys the driving. So, but still, so we have to protect people from the people like me. And also, we have to protect people, like me, maybe. So, and I think that, there's the autonomous driving also will not go to the 100% market penetrations because of me, right? I will not give up the driving. So I think that many people will not give up driving. So so I think so. So we have to develop some kind of systems for the mixed situation always. So we're gonna have many manually driving vehicles. We're gonna have many autonomous, the vehicle. So we want to find some harmony. So with the people and with the machines. So I think that this is gonna be the, the next big topic, for this society.
Thank you. And if you reflect now on your current projects, we mentioned pedestrians as a challenge or maybe also opportunity, who knows? What other challenges do you think, these are like the biggest roadblocks that we have to overcome?
So actually, smart cities, we only focused on the technology itself. So we are really kind of the techaholics. So everybody talks about the technology, but the problem is that, so how we can make a good, the political, the institutions, and how we can make a good democracy, and how we can get the harmony from the people. I think that's going to be the next big topic. And also, so when you design the digital twin, so if we just go into the technology part, I think the digital twin is not that simple. So we have to consider many things, and we have to develop really a lot of the models. So for example, for the cities, we have to make traffic simulations, and also we have to understand how the peoples are making decisions. They will choose this route or that route. So we have to study more on the people and their choices. So digital twin, this is really kind of the huge job. I think that this cannot be done in very, in several years. So we have to make it maybe more than 20 years and 30 years. I think that that's going to be the biggest challenge in terms of the technology.
I think digital twin is also a very big topic that we read a lot about when it comes to the new digital deal, for instance. So I would assume, or do you expect any more momentum through this government policies, the new deal through the digital twin?
So at this time, our government, there's as a project of the, the digital New Deal, they want to accumulate data. So maybe for the training purposes, they are accumulating a lot of the camera data, and they're accumulating all the data. So I think that this is going to be a lot of the help, to make a more model using some AIs. But I think that the New Deal project, this is only for this Corona era. So I think that so next year, if we overcome this Corona, I think we have to think more more innovative project that goes beyond not just the data. Yeah, that's my view.
Well, before I do my wrap up, let me ask the two of you one last question, if I may, Felix.
Please.
You were, Professor, you were talking about that you're very open for cooperation, international cooperation, especially starting next year with new projects. You are in a company which works internationally as well, which has whose cars are loved by all over the world. How far have you come in international cooperation yet? Do you more focus on a Korean project development and now go outside, or how many corporations have you had so far? And which role did they
With
play with international
international-
players?
Actually, yes, I have several ITS projects and internationally as a project manager before. So yes, I've known about that, how we collaborate with them. However, car OEM makers, it's a little bit different industry field. So we needed to dig more about our partnership. So it could be helpful to broaden our capacity and the industry area.
And so for my side, I think that I joined this project just the 2 months ago. So I have not prepared much on it, but for next 6 months, so we're gonna construct our SPC, the special purpose corporation for this Sejong Smart City, and that here I'm gonna make the concept for the international collaborations. So I think that I'm gonna involve some of the research universities, like the Australian universities, and some the companies in some universities in the Middle East, because I think that so we already have really good connection with some universities, and not just the university wide. We can also want to have some more companies involved, and then I think that after we make some kind of really good product and good research, good result of the researches, then I think that we can make some kind of the marketing together, or the going out together, the using this one. So I think that's if we have any proposals, or if we have any suggestions from the German side, so I think I'm really welcome to all of those kind of ideas.
Well, thank you very much. I'm rather sure that some in our audience watching and listening to us will be happy to hear that from both of you, and because we all know that with an international cooperation, things will work better, they will be faster, and and we have seen so many cases where others had specific solutions where we have been thinking about for quite a long time, and now just through an exchange, which will normally be a win-win situation, we can solve this problem. I've been asked to give a short wrap-up by Felix. I gladly do so, although we have already 1 minute past 5, but I make it brief, I promise you. We have heard what I can say about myself, extremely inspiring presentations. I think also we have had not only an encounter with future. What I have learned is how far we have come already. It was for me let's say, really amazing when we had the question from Felix. When will autonomous driving be widely available? And your answer was, well, maybe next year. Your answer was, let me be a bit conservative, let me be a little bit more considering, maybe, but in the next 10 years. This is, I have to admit that, for me, not being an expert, rather amazing. And so for me, it was a look at the future. For others, it is a look into the present. And I think this is really thrilling what we are going through that and what we are facing. I've learned from Professor Yeo as well that engineers have their own understanding of city. It's a different mindset. And this is not bad, because what you are doing, because being aware of that, you're intensively working with living labs. The Friedrich Naumann Foundation for Freedom does that as well, because in the end, who do we do it for? It's for the people, it's for the citizens, and it's for the development of the whole country. So it's very good that although you are very aware of the fact that there are different mindsets and different ways of thinking, that you try to bring all under one umbrella. I like that very much. We heard from Ailey about the project, a concrete project, and I have to admit I would have loved to continue watching this video a little bit longer with the three categories: the safe driving, the traffic management, and the road management. It's a rather challenging task. 85.4 kilometers are quite considerable dimension of your work. Of course, we are still, and I learned that from both of you, that we are still in an experiment phase, but obviously we are becoming more and more concrete month by month, not only year by year. And so I think what we really can take with us is the dynamics within these developments. But we have also learned from your case study video that you are very thoroughly considering constellations and possible conflicts. So many things are scenarios, but it's getting more and more concrete. Having used up my time almost, I'd like to thank KAIA for the great cooperation. I'd like to thank the KGCCI, and what I can announce at this place, we as Friedrich Naumann Foundation very much look forward to further programs we would like to offer together with our wonderful partners in future, and we would like to be part of this communication process in the future as well. So please, for those who could not join us today, stay tuned. Always read the invitations of KAIA and of KGCCI, and of course the Friedrich Naumann Foundation for Freedom. We are very much looking forward, but nonetheless, one day Corona will be over, and we hope to see you in one of our events in person, and maybe even with shaking hands and having a snack after this. Thank you very much from my side for the great presentations, for the great organization, and of course, mostly important maybe for you, to you for watching us and for your interest. Thank you very much.
Thank you very much.
Thank you very much.
Thank you.